Hey future math wizards! Ever noticed how a basketball arcs through the air or how a fountain spray forms a perfect curve? Those are not just cool visuals. They are examples of conic sections, one of the most fascinating topics in pre-calculus. For today's discussion, I hope you'll be able to distinguish between the four types of conic sections and explain how they are formed by slicing a cone. Similarly, recognize conic sections as important curves in mathematics and relate them to real-life situations. But first, what is pre-calculus? This course covers various topics in analytic geometry including conic sections, systems of nonlinear equations, series and mathematical induction, circular and trigonometric functions, trigonometric identities, and the polar coordinate system. Quite a lot, right? But don't worry. Now we'll just focus on how shapes are formed by slicing a cone. So what are conic sections and why do they show up in sports, design, or even in space? A conic section, or simply conics, is the intersection of a plane and a right circular cone. A line lying on the cone is referred to as a generator. There are actually four basic types of conics. Let's start with circles. A circle is formed when a plane parallel to the base crosses one of the cones. All points on a circle are equally distant from a central point. Think of coins, pizzas, and even wheels as an example. How fascinating, right? Moving on with parabolas. A parabola is formed when the plane is tilted and becomes parallel to one of the cone's sides. It has a distinct U shape and reflects light or sound to a single point called the focus. This answers our question earlier. Basketball arcs and fountain sprays follow a parabolic path. The third one would be ellipses. An ellipse is quite similar to a circle. However, the difference is that it is tilted at an angle and crosses only one side of the cone. An ellipse has two foci, and the sum of distances from any point on the curve to each focus is constant. Look at running tracks, planetary orbits, or even eggs. Last but not the least are hyperbolas. A hyperbola is formed when the plane is tilted further so that it intersects both cones. It has two separate curves that mirror each other and often model paths of particles or waves. Here, the inward curve between the upper and lower bouts of the guitar and the curved sides near the narrow middle of an hourglass resemble hyperbolas. And now, can you think of your own examples for each conic section? And that's a wrap on our journey through the world of conic sections. Keep exploring and you'll never know what discoveries you'll make next.